You know, when we think about AI, our minds usually go to chatbots, writing emails, or creating some wild images. But what if I told you the real AI revolution, the one that's going to change everything, is happening somewhere you might not expect? In the laboratory. We're about to dive into how that very same tech is now being used to decode and maybe even rewrite the code of life itself.
And that really is the million-dollar question, isn't it? We're seeing this incredible shift from AI being a kind of helpful assistant to becoming a genuine partner in science. So yeah, the question isn't if AI can help invent new medicines anymore. It's really about how fast and how profoundly it's going to reshape biology as we know it.
Okay, so take a look at this. It's basically a map of the AI universe right now. And if you squint, you'll see this tiny but super important slice labeled biology. Yeah, it's only 3%, but trust me, that's where the next frontier is opening up. And get this, look who's making the big bets. A whopping 88% of these models come from industry. This isn't just some academic side project. This is big tech and big pharma going all in.
So how in the world does a tool that was built for understanding language, like chatbots, suddenly jump into a biology lab? Well, it turns out that all of that dense, complex scientific research, all those papers, it's just another language. And large language models, or LLMs, are becoming fluent. They're able to read and connect dots across a mountain of data that no single human ever could. Just try to wrap your head around this number. Over 125,000 research papers, and that's just in one specific subfield of biology. I mean, could you read all of that? No way, but an LLM can. It can basically treat all of that human knowledge like a single searchable library, finding connections that we never even knew were there.
Now, to really get why AI is such a game changer here, you first have to understand the core problem. See, engineering biology isn't like building with Legos, where everything just snaps together. It's way more like trying to edit the recipe for a cake while it's already baking in the oven. It is slow, it's unpredictable, and it is incredibly, incredibly difficult.
And this leads us right to the field of synthetic biology. People in the know call it SynBio. You can think of it as biology as engineering. The whole goal is to design and build brand new biological systems from the ground up, like, say, programming bacteria to produce medicine or creating yeast that can brew biofuels. Really cool stuff.
And for decades, this is how it's been done. This is the traditional scientific grind, the design, build, test, learn cycle. You get an idea, you build it in the lab, you test it to see if it works, and let's be honest, most of the time it doesn't. So you learn from that failure and you start all over again. Each turn of this wheel can take months, sometimes years. This has been the bottleneck holding back innovation for ages.
But this is where that slow, grinding cycle just gets completely shattered. AI is stepping into the lab not to replace the scientist, but to become the most powerful research assistant in human history. It's capable of supercharging every single step of that process.
And this chart right here, this is the aha moment. It's brilliant. Look at those bars on the left. That's a standard off-the-shelf LLM trying to answer really tough biology questions. Its accuracy? Pretty bad, right? Around 25%. But then you feed it those 125,000 papers, first the summaries, then the full text, and boom! Look at the right. Its accuracy skyrockets to over 85%. It goes from just guessing to genuinely understanding the science.
So how does the AI make this incredible jump? It's not magic, it's a specific technique called Retrieval-Augmented Generation, or RAG for short. Think of it like this. RAG basically gives the AI a library card to a super specialized library. So before it gives an answer, it can go to a trusted source, in this case all those scientific papers, and look up the correct information. That's what makes it so incredibly powerful.
And here's what that new reality looks like. This diagram shows that old, slow cycle being totally transformed into this sleek, accelerated pipeline. You can literally see these little AI agents plugging into every single stage, helping design the experiment, analyzing the results, and even predicting what the best next step should be. It's a complete reinvention of how we do science.
The endgame here, the ultimate goal, is something straight out of science fiction. The self-driving laboratory. This is a future where the AI doesn't just suggest the next experiment, it actually runs it, using robotics and automation to do the work, 24/7 without ever getting tired. It's a vision of scientific discovery moving at the speed of computers. Okay, but with this unbelievable new power comes immense responsibility. We have to talk about this. This technology isn't just about making better biofuels or plastics. Fundamentally, this is about the power to design life itself. and a power that profound cuts both ways. And right here is that dilemma in its starkest form. The exact same tool that could help us find cures for cancer could, in the wrong hands, be used to design new and more dangerous diseases. The promise and the peril, they are two sides of the very same coin.
One of the researchers involved put the stakes in really chilling terms. They framed it as a race against time, a race between those who might want to misuse this power and the safety experts who are scrambling to build the guardrails to stop them. And that race is happening right now.
And these risks are very real. I mean, they range from the terrifying idea of AI-designed bioweapons all the way to the more familiar challenges we see with tech, like data privacy breaches and intellectual property theft. These aren't just little details to figure out later. They are absolutely central to how this technology develops.
So, where do we go from here? What does the lab of the future actually look like? Well, we are standing on the edge of an incredible new era in science, but it's an era that comes with some very profound new questions. Navigating this future is going to require more than just scientific brilliance. It's going to require wisdom.
And this really is the most important takeaway. The solution isn't to slam the brakes on this incredible technology. You can't put this genie back in the bottle. Instead, the focus has to be on building the right frameworks, the right security, and the global cooperation we need to harness this power for good and do it responsibly.
And all of this leads us to one last, really big question. We started by asking if AI could invent a new medicine. But maybe the real question we should be asking is this: is AI on the verge of inventing a whole new kind of science altogether? One that's faster, more powerful, and eventually completely autonomous.